again, Homo Dysons, and welcome back to 300 Seconds of Science. Something happened in the science world that's making some gnarly waves. You can't curl these rippers, if you know what I mean. Surfing jokes, ha! No, but seriously, this is gonna change your lives. Welcome to 300 Seconds of Science. I'm Adam Bonomo, and today we're talking about the existence of gravitational waves, how they can help us, but first I'm going to talk about why do they exist in the first place. So like any great story, we have to start from the beginning. Except for Peter Jackson's King Kong. That one, you can skip the first hour or so.
And they all lived happily ever after. Did you like that story, Kong?
We must go back 100 years. To when Einstein was working on his theory of relativity. So, gravitational waves are a consequence of relativity because something would have to cause light to have a finite speed, which were predicted to be gravitational waves, or at the time, gravitational radiation. Thus, the idea of gravitational waves was born. Yeah, might as well revolutionize the way we see the universe with the idea of the speed of light. And while we're at it, predict a discovery 100 years in the future. Einstein, man. He's crazy. So on February 11th, 2016, which is this year by the way, the Laser Interferometer Gravitational Wave Observatory, or LIGOS, discovered the existence of gravitational waves. The way they did this is they made an observatory that had two arms that each stretched over 4 kilometers. Now from the center, a laser would be shot in both directions of the arms, and then it would be reflected back to the center. The observatory would be able to detect any sudden movement down to less than the size of an atom. What I'm saying is it's really, really precise. These aren't something we can see with our eyes. Like an eagle that eats carrots every day with a microscope couldn't see these changes. Like it took 2 different LIGOS to find this discovery, one in Hanford and the other in Livingston. I know what you're thinking. Adam, what are gravitational waves? Okay, so for this, I'm going to have you guys think about doing some sick dance moves with your dance comrade on a rickety floor that shakes every time you step on it. Every time you take a step, there's a wave that is being sent through the floorboards up into the wall, and it makes both of them shake. Now scale is up to an intergalactic do-si-do, and instead of it being you and your dance comrade, it is 2 supermassive black holes that, instead of dancing, are spinning into each other, and instead of sending waves throughout your floorboards, it is sending waves throughout the entire universe. So with all this new information, you might ask, what will we learn from this? And no, right now the possibilities are endless. Although the different kind of gravitational waves the universe makes fall into 4 different categories. To start things off, we're going to talk about the type of wave that we actually detected. Great job! Which is super fast moving objects, like the 2 black holes we were talking about earlier that we're getting their intergalactic merge on. Although right now, LIGOS is pretty weak, and I'm not trying to discredit any of the science behind it. It's just these are the only waves that we can effectively see right now. In years to come, better laser interferometer gravitational wave observatories will be made. Like the one we have can only detect things between 1 and 10,000 hertz. It's like how humans can only see a certain part of the spectrum of light, or how we can only hear things between 20 hertz and 20 kilohertz. So now we can move on to the next type of wave. Slower waves are created by the presence of massive objects, like the supermassive black hole at the center of our galaxy, as well as other black holes throughout the universe. These waves just aren't as powerful because it's one lone black hole without any real movement going on to influence it. Now the third type of wave is the ultramassive black hole orbit. So to be clear, in order to make detectable waves, these objects have to be massive, which is why so many of them sound similar, but this one is whenever 2 massive black holes are just orbiting each other. The final wave group is called the relic gravitational wave radiation from the Big Bang, which I know sounds really cool. If we could trace these well enough, we would be able to reconstruct early moments of the universe and would broaden our understanding of everything we know. Each one of these waves will heavily influence our perception of how the universe works. Science being awesome yet again. Anyway, if you guys like this type of information, go and like us on Facebook, follow us on Twitter, and subscribe on YouTube. I'm Adam Bonomo, and that was 300 Seconds of Science. So go out, enjoy life, and stay curious.